Thanks, Richard. Good morning, everyone. I'm Peter Stoker. I'm the Chief Engineer for Connected and Autonomous Vehicles at UTAC at the Millbrook location. We used to be called Millbrook. We're now known as UTAC, hence the branding change. I'm on bandwidth saving, so I shall switch off my camera and guide you through the presentation. A lot of things I'm going to cover will be interesting because some of them reflect what James has just presented to you as well, and there is a reason for that, that we are designed to supplement the public road test beds by offering an earlier stage controlled facility. So I'm going to talk to you about the UK's controlled urban Cavern 5G transport testbed, which we have two testbeds in different locations. So one through CCAV, one through DCMS, which will cover connectivity, automation and simulation. If I move on to next slide. So this is an overview of our connectivity that we have at the UTAC Millbrook location. So for those interested in connectivity, devices, services, etc., we have around 59 masts with around 100 base stations. We operate private networks in 4G and 5G standalone, in millimeter wave, in DSRC. We have high definition CCTV, lots of fibre and power, and very accurate locations, object to object, anywhere on the site. So it's a very highly intensive, hyperdense, small cell network. You have your own SIM cards, so you can come along and test, and as we say, fail in private. The ability of a private network is we can turn it on and off, up and down, and so on. At the Culham location, which is located just by Abingdon in Oxfordshire, is the home of the UK Atomic Energy Authority. They have a division called RACE, which is Remote Applications in Challenging Environments. And so RACE are interested in robots, well, autonomous vehicles and challenging environments, the public roads, hence the idea for the collaboration. But also we have access between us to the 200-acre site that's located at Culham with its roads and everything else I'll come to. So the original proposition of our joint project was to offer test services to the industry, including new facilities, a simulation suite. What was innovative, it's a clear pathway to on-road operation, as we just heard from James. It's open to everybody. And because we're independent and impartial, we're not a threat to customers' IP or any compromise on that. We test vehicles, components, systems, and now services. We have lots of space, lots of tracks, and lots of endless scenarios and use cases. And we're open to startups, SMEs, OEMs and consortia. And indeed, from the last SME program you saw on the video, we had quite a few of that cohort actually testing with us in both locations. What have we been up to? We've been doing a lot of work in terms of networks. We've been neutral hosting. We've been sending a lot of high-speed data backwards and forwards and overloading cellular networks. We've run some really interesting use cases in healthcare, in high-speed rail. We do live data broadcasts between vehicles. We do video calls at 100 miles an hour and remote vehicle driving. The sort of high-speed data we can pursue is around about 1.6 to 3 gigabits per second at 160 miles an hour, which is a high-speed rail use case. We're doing lots of work on CAV testing for AI development in ADAS, in safety drivers, different vehicle types. And we've seen lots of different people, startups, SMEs, OEMs, mobile operators, infrastructure providers, regulators, drones, and even local authorities. So what sort of accommodation could you see? So this is our self-contained little CAV village where we can get collaborators to come and work together, either individually or collaboratively. It's right in the middle of the test tracks. There's no long drives to get to the tracks that you might need to use or the networks you might need to access. We have at Culham the same kind of thing. So we have secure garages with office accommodation as well. So people can stay for half a day, a week, a month, a year. We don't mind. Lots of different road types at Culham as well. So more a semi-controlled site, but with people and vehicles and obstacles and road features. So here you can see a lot of signage, a lot of different vehicle types. We have a lot of junction types as well, and very flexible facilities that we can recreate road environments with sort of temporary paving and curbs and things like this. Active safety. If you're working in this area, we have targets available. So we have cyclists, motorcyclists, pedestrians. We've got road signs, street lights, very accurate positioning, and a lot of good high-speed multi-channel data logging as well if you're dealing in this area. And particularly with signs, we don't just show nice clear road signs, obstructed signs, illegible signs, spoofed signs, whatever we need to do. And also lots of different vehicles. Again, if you're working in collision or you're working in collision protection or AI, then we do offer the ability to look at robot controlled vehicles as well as steering and pedal robots to operate your vehicle under test. As well as a physical environment, we have a virtual environment. We have a very accurate digital environment at Millbrook tracks, resolutions around 1 millimeter in Z. And on the bottom there, you can see left is virtual, right hand is real. So we have most of our tracks covered. We have a driver in the loop simulator. We have a vehicle in the loop simulator as well. We can show vehicles the tracks themselves, give them data from radar, LiDAR, camera, etc. And again, we can cover different weather types, different traffic types, and all kinds of different simulated scenarios, because actually nobody generally gets hurt in the simulator. At Culham, we have a digital model of Culham that's available to use, and also LiDAR scans, real and virtual. In terms of simulation, we were able to reproduce a lot of different ADAS standard scenarios. This one is a very quick sort of autonomous emergency braking scenario that we run in simulation, and we can also correlate it to the real environment on the tracks. If you need a vehicle, like James, we have some open source vehicles. Just remove that lobby sticker, which are provided by Street Ground. So we have 3, so you can platoon, you can orchestrate, you can do all kinds of different things with it. The guy in the bottom middle picture is actually remote vehicle operating. So he's driving a vehicle from inside the garage out on our tracks using our network with high bandwidth and low latency, and again, under complete control. If you have devices, then we have a range of masts that we can deploy these on. These are tiltable, so you don't necessarily need working at height permits to do this. So we can add on devices and services and link them into our fiber and power network if we need to do that. So these are the 4G 5G small cells located around Millbrook. At Culham, we have the same type of connectivity and CCTV. So we cover the site at Culham, and again, the same ability to tilt down and attach your own devices if you need to. High definition CCTV at Millbrook, covering the whole of the track area. This is confidential. It's not available for broadcast, but with discussion with customers, then we can record and monitor your particular trials and tests that are going on. We have high bandwidth, high speed, low latency communications. This is a use case for high speed rail using 70 gigahertz millimeter wave, and the vehicle itself is orbiting with a train antenna on the top. This is giving us aggregate throughputs of around 1.6 gigabits per second and peak up to about 3.1 gigabits with an end-to-end latency of less than 1 millisecond. So if you want to transmit high bandwidth, low latency data, this is the place to do this. It's actually a high-speed rail use case, not a McLaren 570S use case test. We've worked in the past with ambulances, so as a 5G experiment with ambulance, transmitting high-definition patient data from location to hospital consultant, and high-definition multi-channel data logging, which we do on a live basis. So this video is speeded up, but it's just showing that we synchronize video, GPS speed, lots of different vehicle characteristics, and this is transmitted live back to the engineer's desk, where we're able to view the data, check sensors, and so on. Just trying to remove lobby data. So again, we're recording engine speed, gear position, steering angle, throttle pedal, etc. The other side is overload tests. So if you do have a service that you need to test with other conflicting ones, this is a test we ran with downlinking videos, uplinking videos, Google Duo calls, and PC video conferences, all going on at the same time in the back of a car at 70 miles an hour. So we can stress networks as well if we need to. So I'll leave you with just a view of Millbrook and move on to the contact details. So you'll see myself here, Peter Stoker. Sal Ahmed is our business development person. Gary Staunton is the lead technology at UK Atomic Energy Authority. But even better than contacting us, come and see us at the LCV CAM exhibition on the 22nd and 23rd of September, which is located at UTAC's Millbrook Proving Ground. And bring your driving license, because there may be a chance you get to drive our tracks. So hopefully that's given you a very short introduction. I'm happy to share all these slides with everybody, and I'll hand back to Richard.